Okay, hi everyone. Welcome to the lecture for Git. So this is the first exercise. I'm just going to run through and sort of break up this lecture into a few little chunks, all the different bits. Sort of like each little quick video will do one little feature of Git, mainly because this lecture's little video series can be reused for other courses and whatnot. So this is going to be quite abstracted. It's not ESPL specific. This is just Git. So Git is used everywhere in software. So with that said, I'll give a quick introduction to Git and then I'll go into the features of it and I'll give little examples on my laptop about everything while I go. So just checking my screen is recording. Nope. Starts recording. So what is Git? So Git was developed, firstly who it was created by Linus Torvalds, and he is the creator and maintainer of the Linux kernel. So it is very much a mature software and developed by the best of the best. So it has sort of become the industry standard in version control software. So there was the software that was bigger before this was VCS. I, in my life, have never used VCS. Because obviously in 2005, while I was writing code, I was not really that serious about it. So anyway, the difference between Git and sort of like VCS is that it works in like a very much a distributed fashion, in that there's each person has a copy of the repository, and then you sort of choose when you can update and send changes between certain copies, right? So now it all starts with repositories, and should make this a bit bigger. So a repository is essentially, why is this not? Anyway, okay. So a repository, or like as I'll probably say is a repo, is essentially a folder on your laptop or on your system where the code is stored, and it looks like a folder to you and I when we interface with it. But really, what Git does is it builds up a little file system, and this file system where you work in and develop your code is controlled, or not controlled, but sort of it's really looked after by Git. Like Git is very active and it's integrated sort of into everything you do in the directory. So it's very seamless in that you think you're sort of just interacting with normal folder structures, but really Git's in the background doing a lot of cool things. So the changes, like when you clone this repository into a certain folder, the Git will take care of everything in that folder, and so you can only do like any changes that happen in that folder will be managed by Git. So this can be a bit tricky when you want to sort of link in external folders and whatnot. But yeah, so changes in this file system, I'll have a slide in a minute that sort of show how Git differs from classic version control. Then Git sort of just snapshots the entire directory. It doesn't like create deltas explicitly. Like you can show patches, and it's able to generate deltas of like the changes. But Git works in that it actually creates snapshots of the file system, your repository, whenever at certain points in time. And we'll get to when we do this. This is done through committing, and this is one of the first things that we'll get into. But it's good in that it creates these snapshots because it adds a lot of speed as well, but also the flexibility in it is quite immense, that you can sort of check out these different snapshots and they're a very much complete snapshot of the entire repository state. The way that Git works is that you have, as terms of the server and the client, you create a repository. Like when you create one such as on GitLab, on GitHub, you can even run a Git server on your laptop locally. But essentially you create a repository on some remote server. And I'm using the word remote here because this, as we'll see later when we get into actually using commands, the word remote is the Git terminology for the server somewhere where something is stored. And you can have multiple servers getting pointed to from a repository. If I have like my main server and a backup, I can sort of I can interact with these two remotes separately, right? But what happens is that this remote, such as from all my examples, I'll use GitHub because it's the most popular and most common sort of Git service used. So if you have a GitHub repository, your remote is on the GitHub servers somewhere, right? And you'll have a local copy on your laptop, and then you have to sort of synchronize the two. Git doesn't work like these other sync protocols, but it's more of a manual. You choose when and what to sync with the remote, right? Configurations, a little quick thing. If you want to look into the remote, for instance, when we generate a default repository, these are all stored in the .git folder, which is a hidden folder in the config file. As a basic user of Git, you probably wouldn't need to mess around with this file too much, but it's useful if you want to go in and look at, for instance, the remote, because the remote is like all your remotes are stored in this config file. So creating a repository is usually quite easy, and it's done usually via a web interface, because the web interface lets you sort of access the service like GitHub and GitLab, and also create the repository on their remote server. Because you can initialize a Git folder on your laptop quite easily from the command line, but to actually create the repository on the remote where you're going to send your changes to, this requires you to create this repository, and this is usually done via web interfaces. So I will quickly just jump over now to GitHub, and we'll create a new repository for the point of this. Am I connected to the network? Yes. So now on GitHub, for instance, once you created a profile, you'll get hit with this, like here, you can choose a new repository. Now, there are a few different things that you can add to your repository by default. So there's the readme.txt, and this is actually wrong. This should be .md because it's markdown. So this is a markdown file, and this means that you can format it. So if we look at just quickly one of mine, so I open a tab. Look, for instance, here, this is the piece of software that you'll use. You have you can add in images, or these are all just images, links, titles, code snippets, and this is all done via Markdown. So if we look quickly at the raw of it, you can see that there's these formatting whatnots. And so that's the useful thing of the README. The README is generally there for sort of explaining the repository, giving instructions, giving credit, dependencies and whatnot. So you have the README, which is generally important, especially if you're going to share your code. The license, so this one is also important for open source code projects as well the FreeRTOS emulator, where it's under a GPL license, meaning that anyone is free to take it, change it, use it, whatever they want. So this is sort of important when you come to open source and projects that you think people might want to take, and it's totally up to you. I would recommend looking into the GPL license, and the MIT license is also another quite attractive license. So the git ignore, we'll get to this a little later. What this does, essentially, this is just sort of like a filter to tell you what files you don't want Git to use. Essentially, just if you're doing a project like a C project where you generate a lot of build files, like object files and CMake caches and whatnot, then Git will ignore this, because the general idea or the general best practice of Git is to not include binaries, temp files in a repository, unless, for instance, sometimes you'll include binaries if you're releasing some sort of a precompiled binary. But generally, you want to try and avoid including these sort of generated files, right? So now we want to create a repository. Quickly in the interface, oops, wrong screen, we'll say git lecture, the repository used for the Git lecture, right? And so I'm going to make it public. Anyone can find it then on GitHub. We'll create it with a README. Now let's just say, for example, we wanted to make a C project. There are some sort of template git ignore files from GitHub that are quite useful. And if you look into the git ignore, and once it's generated, it'll have sort of the basics, like it'll ignore object files and all this sort of stuff. Add a license, yep, we'll add a GPL license, and then we'll create a repository. And so now we'll get greeted with the sort of the repository screen. This is the contents of the repository. If you create it, for instance, in GitLab, which usually doesn't actually create like add these files into it. It sort of gives you a command line instructions on how to initialize the repository on your local system. You sort of just follow the instructions, right? And the GitLab will probably have you doing a git init instead and add the remote and then push. But now that we've created our repository on the web interface, we can clone it. It exists on GitHub now. So really got to stop going to that page. So here, there's a link for download, for cloning it. Now there's SSH or HTTPS. SSH means that you'll generate an SSH key on your computer, and then you'll upload it to your profile on GitHub. So in settings, there is a little tab where you can add SSH keys. So if you want to add an SSH key, Google adding SSH key to GitHub. There's plenty of documentation on it. It's really straightforward. But the advantage of an SSH key is that once you have set up a key pair, you don't need to actually have to type in your credentials every time you want to interact with the server. Well, mainly when you want to push. So when you want to update changes, it requires you to authenticate them. And so if you have an SSH key uploaded to your profile, this is automatic. But if you don't and you're using HTTPS, then every single time you have to type in your username and password, and it can become quite tedious. So anyway, I have my SSH key uploaded, so I'm going to use SSH. So now we are going to open a terminal, and I'll just do it in my home directory. So I'll git clone, and then I will you just put in the the link, and you'll see here, even though my home directory is probably a little messy, you'll find here we have git lecture, right? So if we go into this folder, git lecture, we will see the contents. Now, if we look at the hidden contents as well, we will also see that there's this the git ignore here. And so if we look inside the git ignore, you'll see that there's all of these sort of filters, generally done with wildcards. And this was done as I select a C template. You can see you have general object files, Linux kernel object files, sort of embedded system ELF files, linker maps, and all of this stuff. So whenever I generate a build or compile some code, it will not add this stuff to Git. But we'll get to this in a bit. So that is generally creating a repository. So now I will do a quick introduction to committing, because committing is the basis of how you interact with Git. So